Determine whether functions f and g are inverses. So what I'm looking at here is this y equals x would be my mirror. And so when I look at one of these graphs, I look at like let's say this point right here on my graph. If it was really showing inverses, the mirror point would be over here. And like maybe this point would be like this point. So if I reflect the blue one, it's going to look something like that. Okay, if I reflect it over y equals x. Since that does not happen, these can't be inverses. Then I look at the other one. I look at this one, and it's pretty obvious. It's pretty obvious that we're talking about a reflection. Okay, these points are reflected over that mirror. These are inverses. Number 8, let f of x equal x squared plus 4. When x is less than or equal 0, find the inverse. Okay, so something kind of important is this x is less than or equal 0. If you were going to picture this function, you might say, well, x squared plus 4 looks like a parabola that's been shifted up 4. Okay? And if I do the horizontal line test, that means it's not 1 to 1, so this can't have an inverse. So why is this problem telling me to find the inverse when I know it doesn't have an inverse? Okay? But that's why you have to look at this x is less than or equal 0. They're doing something here called restricting the domain. They're restricting the domain. The domain doesn't include that whole half of the graph. Really, if you think about x is less than or equal 0, then there isn't a right side of this parabola. And if there's only this part of the parabola, this part does pass the horizontal line test. So if I only look at half of the parabola, it is 1 to 1 and it will have an inverse. And so that's what they've done here, is they have restricted the domain. So we want to find the inverse of the restricted half parabola, I guess. So y equals x squared plus 4. We're just going to do what we've done. X is less than or equal 0. Switch x and y. And then isolate y. So I'm going to subtract 4. And what's going to knock off my square? Square root. Okay, so here's something that's kind of tricky. Okay, this is the trickiest part of the problem. When I do the square root of both sides, technically, normally, I would do the plus or minus square root. Okay? Plus or minus square root. But when I restricted the domain and said x was less than or equal 0, and then when I switched x and y, it now says y is less than or equal 0. So you're not going to do the plus or minus square root because y has to be less than or equal to 0. You're only going to use the minus part, the negative root. And so our inverse is going to be f inverse of x equals negative square root of x minus 4. Okay, there are some important facts about inverses. You can go through and read those. We're going to move on to example 9. Example 9 is kind of fun because it's like a secret code. It says the function f of x equals 3x minus 1 was used to encode a message as 11, 44, 74, 44, so on. Find the inverse function and decode the message using this chart. Okay, so we're going to have to find the inverse of this function. Switch x and y. Add the 1 over. We're going to isolate y. Divide by 3. Y equals x plus 1 over 3. Or f inverse equals x plus 1 over 3. That's what we're going to use to decode the message. So the encoded message was 11, 44, 74, 44, 62, 59, 68, 14, 14, 59. Okay, So that first number is 11. Plug in 11 right here into your inverse. 11 plus 1 is 12, and 12 divided by 3 is 4. So find 4 in the chart. That's the letter D. 44. Plug it in. You get 44 plus 1 is 45. Over 3 is 15, which is the letter O. 74 plus 1 is 75. Divided by 3 is 25. It's the Y. 44 plus 1 is 45. We already did that one anyway. That's 15, which is an O. 62 plus 1 is 63. Divided by 3 is 21, I believe. 21, that's U. 59 plus 1 is 60. Divided by 3 is 20. That's T. 68 plus 1 is 69. Divided by 3 is 23. That is a W. 14 plus 1 is 15. Divided by 3 is 5. That's an E, so this next one must be the same thing, E. And 59 we already did was 20. That's also a T. Do you tweet? Do you tweet? There's the encoded message. Okay, so I think that's kind of neat.
That was very anticlimactic.